Hi, this is Mrs. Baisden, and today we're going to talk about stoichiometry. So stoichiometry is the process of using chemical equations to figure out relative masses of reactants and products in a chemical reaction. So a balanced chemical equation that we've learned how to write over the past couple of chapters is like a recipe for how reactants combine to form products. So it tells us how many reactants we need to make a certain amount of products. The coefficients in that balanced equation show us the relationship between the reactants and products. So these coefficients we refer to as the mole ratio, and those can be used as a conversion factor when we do these calculations. So the easiest way to learn how to do stoichiometry is to actually do the calculations. So we're going to start with this roadmap. So this is kind of our overall path that we could potentially have to take to solve for grams of one substance given grams of another substance. Now, sometimes you'll need just part of this pathway, sometimes you'll need the whole thing, and we'll go through examples of what each one of those things would look like. So when you look at this and when you're doing a stoichiometry problem, you're going to be given one substance and it's going to ask you how much of another substance could you produce or would you need. So when you look at this, you're going to find your starting point on this pathway and then you're going to use the conversion factors to get to where you want to be. So to get from grams of one substance to moles of another substance, we're going to go back and use that molar mass from the periodic table. So this is similar to conversions we've done in the past. So 1 mole of any substance is equal to the molar mass in grams from the periodic table. Same thing applies over here. 1 mole of a substance equals molar mass in grams from the periodic table. So then the other conversion we'll need is a new one. This is when we're going from moles of one substance to moles of another substance. This comes from the mole ratio, which comes from the coefficients from the balanced equation. Okay, so what we're going to do is we're going to go through an example of each possible type, and we're going to refer to this pathway as we go so you can see how this works. So again, anytime you're going from grams to moles or moles to grams, you're going to use that molar mass in grams from the periodic table, just like we've done before. That's equal to 1 mole. Now, where you're going to have a possibility where the number in front of moles could be different than 1 is when you get that mole ratio, which comes from those coefficients from the balanced equation. Okay, so the simplest type of stoichiometry problems are mole-to-mole problems. So this is when they give you moles of one substance and they ask you to find moles of another substance. Every single one of these problems is going to start with a balanced equation. So sometimes the balanced equation would be given, sometimes the description of the reaction would be given. That's what we did in the last unit. So now that you know how to do that, you know how to start all of these problems. So you can't do anything with the stoichiometry until you have that balanced equation. So these examples that we do today, we're going to use the decomposition of water. So we're going to use the same equation for every one of these. But we're going to go through and do some different calculations based on what's being asked in each particular question. So for this first one, it says how many moles of oxygen are produced when 2 moles of water decompose. Now, what I like to do with these is to kind of underline what I'm dealing with. And then I'm going to do the same thing in the balanced equation. So I want to know how many moles of oxygen are produced when 2 moles of water decompose. So whenever we're doing this, we're only going to need 2 of the substances in the balanced equation. You could have more than just 3 substances total. You could have 4 or 5, but you only are going to need to deal with 2 of them at a time. So when you start these, just like we did before, we're always going to start with the number that's given in the problem. So we're going to start with 2 moles of water. Now, even more important in this unit is labeling what the substances are and most definitely labeling the units, because this is how we're going to keep track of what to do next as we're going through and using this problem solving method. So we're starting with 2 moles of water. We want to get to moles of oxygen. So if we look at our pathway at the bottom here, we're going from moles of one thing to moles of something else. So we only need the middle part of this pathway. And if you remember from the previous slide, to get to from moles of one thing to moles of something else, all I need is the mole ratio from the balanced equation, which comes from those coefficients. So according to this equation, for every 2 moles of water that decompose, I produce 1 mole of oxygen. So that's what we call the mole ratio. So what I'm going to do here is I'm going to make my bracket, just like I did the last time we did conversions. And I have 1 mole of oxygen for every 2 moles of H2O. And the way I decide what goes on the top, what goes on the bottom, is just like I did when we did conversions before. Whatever I start with, that's what has to go on the bottom. So 2 moles of H2O. And then 1 mole, what I'm trying to find, goes on the top. 1 mole of O2 on the top. And again, just like before, we're going to multiply across, divide top to bottom. So this one, I would end up with 1.0 moles of O2. Again, notice all the labeling. I have the unit and the substance for every single thing I wrote down. We're also going to refer back to our sig figs. So 2 sig figs in the problem, 2 sig figs in my answer. Okay, let's try another one. And I'm going to erase what I already have here so that we can use that same equation again. Okay, this time, how many moles of hydrogen are produced when 5 moles of oxygen are produced? Okay, again, notice it doesn't have to be a reactant and a product. It can be 2 reactants, it can be 2 products. All we're looking for is the relationship between 2 things in the balanced equation. So in this case, I'm using hydrogen and oxygen from the balanced equation. I'm still just doing moles to moles though. Okay, I'm starting with moles, ending with moles. So again, the only thing I need is the coefficients and the mole ratio from that balanced equation. I'm still going to start with what they gave me in the problem. I'm going to label it 5 moles of O2. And I want to know how many moles of hydrogen. So I'm going to refer to my balanced equation and look for my mole ratio. So for every 2 moles of hydrogen that are produced, I also produce 1 mole of oxygen. Same deal as last time. Whatever I started with, that's going to go on the bottom of the next bracket. So 1 mole of O2 goes on the bottom, 2 moles of H2 go on the top. Multiply across, divide top to bottom. This gives me, and I'm going to put a decimal there to show that that's 2 sig figs, 10 moles of H2. So like I said, these are the simplest ones when you're just going moles to moles. Okay, the next type you could have to do are grams to moles. So this one, it's giving you the original substance in grams and it's asking for moles. Again, we're still only dealing with 2 things at a time and the balanced equation. So this one wants to know how many moles of oxygen are produced when 25 grams of water decompose. Just like before, I'm going to start with what's given in the problem, 25 grams of H2O. I'm going to go down to my pathway at the bottom so I can kind of see where I'm going with this. So I'm starting with grams, stopping at moles of something else. So in this case, A is water and B is oxygen. So I'm going to have, first step is to get from grams of A to moles of A. So like we said before, to get from grams to moles, we're always going to use that molar mass from the periodic table. So 1 mole of anything from the periodic table is equal to its molar mass. So if I add up the masses of 2 H's plus 1 O, I get 18.02 grams of H2O. So that gets rid of grams. Now I'm left with moles. Now I go to my mole ratio. So 2 moles of water for every 1 mole of O2. Again, whatever I want to get rid of goes on the bottom. So 2 moles of H2O goes on the bottom. 1 mole of O2 goes on the top. And again, those numbers come from the balanced equation. So the only time I could potentially have a number other than 1 in front of moles is when I'm pulling those from the coefficients from the balanced equation. Again, multiply across, divide top to bottom. 2 sig figs, so 0.69 moles of O2. Okay, another example. I'm going to get rid of this one. This one says how many moles of water are needed to produce 35 grams of oxygen. Okay, so again, from my balanced equation, I'm using water and oxygen. If I go down to my pathway at the bottom, I'm starting at grams, stopping at moles. So I'm starting with grams of one thing, stopping when I get to moles of the other substance. Okay, so I'm going to start with 35 grams of O2. Again, always starting with what's given in the problem. First step is to get from grams of given to moles of given. So I'm going to use my molar mass. So 1 mole will go on the top. Grams would go on the bottom because I want grams to cancel out. O2, look at the periodic table. Oxygen is 16. There's 2 of them. So 32 grams of O2. That gets rid of grams. Now I need to get to moles of water. Refer to your balanced equation and look for your mole ratio. 2 moles of H2O for every 1 mole of O2. I want O2 to cancel, so that goes on the bottom. To 2 moles of H2O. Multiply across, divide top to bottom. 2 sig figs, 2.2 moles of H2O. Okay, so that's the second type. Third type is going from moles to grams. So given moles, asking for grams. So this one says how many grams of water are needed to produce 18 moles of hydrogen. So again, only need 2 things from the balanced equation at a time. So this one I'm looking at water and hydrogen. And then if I go down to my pathway, I'm given moles, I'm asked for grams. So this time I'm going to need the second part of my pathway. Okay, so always starting with what's given, always labeling, because that's what's going to guide me through my conversion. So moles of A, I need to change to moles of B. So I'm trying to go from moles of hydrogen to moles of water. Moles to moles, we use the coefficients from our balanced equation. So that's my mole ratio. 2 moles of water for every 2 moles of H2. I want H2 to cancel, so that's going to go on the bottom. And 2 moles of water on the top. And then last step, I want to go from moles of water to grams of water. So I'm going to use the molar mass. Moles are on the top this time, so 1 mole of water is going to be on the bottom. Molar mass of water, 18.02 grams. Multiply across, divide top to bottom. 2 sig figs, 300. So this ends up being 324 grams. If I'm going to round to sig figs, that would round to 320 grams of H2O. Okay, and when you get to something like this, where you have 2 over 2, which you know is going to cancel out, you still need to write it in the conversion, because that's going to, if you start eliminating things and canceling things out before you get the problem finished, that eventually causes issues. So resist the urge to do that. You want to make sure you write everything in that equation and that conversion as you're writing it out. Okay, one more like this. How many grams of oxygen are produced when 45 moles of water decompose? Okay, so I need water and oxygen. And then if I look down at the bottom, I've given moles of one thing, I want grams of the other. So this one again, we're going from moles of A to grams of B. Starting with what's given in the problem with all the labels. First step, moles of A to moles of B. So I'm going to use a mole ratio. So I go to my balanced equation, 2 moles of water for every 1 mole of oxygen. So moles of water is what I need to cancel, so that has to go on the bottom. So 2 moles of H2O for every 1 mole of O2. And then I want to get to grams of oxygen. So moles of B to grams of B, I'm going to use a molar mass. Molar mass always has 1 mole on the other side of grams. So 1 mole of O2. There's 2 of those, so I have to double that 16. 32 grams of O2. Do the math. 720 grams of O2. Okay, last type is the most involved, but sometimes people feel like this is the easiest because there's no thinking about where to start and where to stop. You always start at one end and end at the other one. So this one goes all the way across that pathway we talked about. So this one wants to know how many grams of hydrogen are produced when 15 grams of water decompose. So again, I'm using water and hydrogen for my balanced equation. I'm given grams of one substance, I'm looking for grams of the other. So this one, I need this whole pathway. And when we're doing labs with this is the type of problems we'll do in lab. Because in lab, we measure in grams, so we'll have to do conversions that go all the way from grams of one substance to grams of something else. Just like always, start with what's given in the problem with all the labels, 15 grams of water. I need to go from grams of A to moles of A. So grams to moles, I'm using molar mass. So 1 mole of H2O is 18.02 grams. Okay, so now I'm here. Now I want to get from moles of one thing to moles of something else. That's where I go to my balanced equation and look at my coefficients to get my mole ratio. So mole of water, I want to cancel. So moles of water goes on the bottom. 2 moles of hydrogen, that's what I'm trying to find, goes on the top. Okay, I'm not done yet though because I want to be in grams of hydrogen. So now I'm going from moles of B to grams of B. Now I do a molar mass. Mole is what I want to cancel. Molar mass always has 1 mole on one side. 2.02 grams of hydrogen from the periodic table on the other side. Do the math, 1.7 grams of H2. So again, grams to moles to moles to grams. Grams of the first substance, change to moles using the molar mass. Change from moles of one substance to moles of another substance using the mole ratio from the balanced equation. Then moles of the second substance back to grams of the second substance. Use your molar mass from the periodic table. Okay, last example. How many grams of water are needed to produce 125 grams of hydrogen? So this time we're using water and hydrogen from our equation. Grams of one substance to grams of another. Same one here. We're going all the way across. We're starting with grams, going to moles of the second substance, and then back to grams. Start with what's in the problem. With all the labels. Grams of A, I need to get to moles of A. So grams to moles is a molar mass. I want grams on the bottom. So molar mass of H2 is 2.02 from the periodic table. Anything from the periodic table is always equal to 1 mole. So now I'm here. Now I want to go from moles of A to moles of B. That's where I refer to my mole ratio from the balanced equation. H2 goes on the bottom. 2 moles of water on the top. Now I'm here, but I need to be in grams. So moles of B to grams of B. Back to my molar mass. Moles needs to cancel, so 1 mole on the bottom because this number is coming from the periodic table. Molar mass of water, 18.02 grams of water. My final answer is I end up with 1,115 grams, but I'm going to try to round that to 3 sig figs. So I'm going to make that 1,120 grams. Okay, so those are your 4 different types that you're going to have to do. We will do lots and lots of practice in class, but this is a good tutorial to get you started on how to do each of those different types. It's something you can refer back to. And again, we're going to refer back to this pathway as we work through this. That's always going to let you know where to start, where to stop, remembering that to get from grams to moles of something, use molar mass. moles of one thing to moles of something else, you're going to use the mole ratio from the balanced equation.